The James Webb Space Telescope, already a monument to human ambition and engineering precision, has once again shaken the scientific world with an observation that borders on the unimaginable. Amid the silent depths of interstellar space, it has detected what appears to be artificial illumination emanating from the object designated 3I Atlas, a celestial visitor traveling through our solar neighborhood on a hyperbolic trajectory, similar to the infamous interstellar objects Oumuamua and Borisov. But this time, the data gathered by Webb's instruments defies easy categorization. What should have been a cold, inert rock drifting through cosmic emptiness instead glows faintly but persistently, with a spectrum and temporal pattern that suggests the light is not natural in origin. The discovery has cast a profound and eerie light across the scientific community, sparking debates that stretch far beyond the boundaries of astrophysics. Astronomers are continuing to track a newly spotted object, likely a comet, from outside our solar system. The interloper named 3I Atlas was first spotted on July 1st. When the James Webb Telescope turned its golden mirrors toward 3I Atlas, astronomers expected to find a small rocky interstellar body, perhaps composed of ice and dust, a relic of another star system wandering through the void. Yet, the photometric data began revealing an anomaly that could not be dismissed as reflection or sublimation. The light from the object pulsed at intervals too regular to be random, and its spectral profile contained emission lines inconsistent with any known natural chemical luminescence. The glow was faint, barely above the background cosmic radiation, but distinct enough to persist over multiple observation periods. Webb's sensitive instruments, designed to detect the faintest infrared signals from the early universe, recorded a consistent signal pattern that resembled structured light modulated as though generated by a technological process. The first suspicion was instrumental error. The Webb team meticulously recalibrated sensors, cross-checked data with the Hubble Space Telescope, and verified with ground-based observatories. Yet every confirmation deepened the mystery. The signature remained the same, a soft, rhythmic pulse in the infrared range, repeating at exact intervals over several days of observation. When Webb's near-infrared spectrograph analyzed the frequency spread, it revealed an energy distribution that bore a closer resemblance to a controlled emission source, something akin to the kind of light used in advanced propulsion systems or artificial illumination, designed to operate in the vacuum of space. It was neither reflection nor thermal radiation. It was structured light, coherent in a way that nature rarely achieves without intervention. Scientists began comparing the data to all known natural phenomena: auroral emissions, outgassing events, ionization trails, or reflective glints from tumbling surfaces. None of them fit. The object's trajectory, already established as interstellar, ruled out it being a piece of human-made debris. The energy output of the illumination was too stable to come from sublimation or spontaneous chemical reactions. And most curiously, the light seemed to respond faintly to changes in solar flux, as if compensating for external light levels, maintaining a nearly constant output despite shifts in illumination from the sun. This adaptive behavior, subtle though it was, marked the first truly alarming indicator that what Webb was observing might not be a mere chunk of rock at all. Atlas itself had been catalogued months earlier as another unremarkable interstellar visitor. Its orbital parameters indicated it came from the direction of the Lyra constellation, traveling at immense velocity unlikely to ever return. It was only during a follow-up survey, an attempt to study its composition in infrared, that the strange luminescence was noticed. The faint glimmer appeared as a narrow band emission in the near-infrared spectrum, centered around wavelengths typical for engineered diodes or laser systems. At first, some researchers suggested it might be the result of exotic minerals fluorescing under cosmic radiation. But this hypothesis crumbled when the periodic modulation became clear. Natural fluorescence doesn't switch on and off in exact repeating cycles. Within the scientific community, disbelief gave way to cautious awe. Meetings at NASA, ESA, and the Space Telescope Science Institute quickly became charged with both excitement and apprehension. If confirmed, the detection would represent the first empirical evidence of extraterrestrial technology, a sign that intelligent life had not only emerged elsewhere, but had also created something enduring enough to survive interstellar drift. The implications were staggering. Artificial lights imply energy control, design, and purpose. Even if the source was derelict, a fragment of a long-dead civilization, the very existence of such a construct would rewrite the cosmic narrative. The light from 3I Atlas was not bright enough to be visible to the naked eye, even through large telescopes, but Webb's instruments could dissect it with extraordinary precision. The near-infrared camera captured subtle variations in intensity, while the mid-infrared instrument detected faint heat signatures inconsistent with a natural body of that size. The object seemed warmer than expected, given its distance from any star, its temperature hovering slightly above what physics predicted for an inert rock drifting through interstellar cold. This excess heat, while minimal, hinted at either residual power or ongoing energy generation. Such a result sent theorists into a frenzy. Could it be a fragment of a probe, a decaying vessel, a self-contained light source powered by an ancient reactor, still weakly functioning after millions of years? As data accumulated, models were built to simulate what kind of artificial mechanism could sustain such a mission. Some physicists proposed that the light might be generated by photovoltaic remnants or by photonic propulsion systems designed to maintain stability in flight. Others suggested the glow could be an automated beacon, pulsing intentionally to announce presence, or more hauntingly, to navigate between star systems. The regularity of its signal resembled a code. Though decoding it proved fruitless, it lacked the structured information content typical of communication, appearing instead as a maintenance rhythm, a repeating sequence to preserve synchronization or control. What made the finding even more compelling was that the emission appeared localized. It wasn't diffused across the object's surface, but concentrated in small defined points, suggesting discrete sources rather than a global glow. Webb's high-resolution imagery, though limited by distance, hinted at tiny reflective or radiative nodes distributed across the surface, perhaps panels, apertures, or light sources embedded in a rigid structure. This distribution was inconsistent with a natural asteroid or comet nucleus, both of which exhibit irregular albedo patterns. The data hinted at geometry, arrangement, order, and symmetry, and those are hallmarks of design. While some astronomers urged caution, pointing to the dangers of wishful interpretation, others argued that the burden of proof was now on those claiming it wasn't artificial. Nature, after all, seldom arranges matter in ways that pulse rhythmically, emit structured infrared light, and sustain temperature anomalies in the freezing dark of space. The object's consistent signal over weeks of observation suggested durability and intention. It was as if 3I Atlas carried a light that refused to die, a whisper from across the stars preserved in photons. The discovery has ignited new debates about the probability of interstellar artifacts and the longevity of technological civilizations. If 3I Atlas truly bears artificial light, it means that some civilization somewhere mastered not only technology, but interstellar engineering, sending objects capable of surviving cosmic radiation, micrometeoroid bombardment, and eons of travel. It also forces a re-evaluation of how we define life's persistence in the universe. Perhaps the true legacy of intelligence is not biological survival, but technological endurance. If the lights are remnants of machinery, they may have been shining long after their makers vanished, drifting silently between stars, a cosmic tombstone glowing in the night.